All right, so we are now going to look at how you take the data from assignment 1.5, where you were making fog marks appear on a bathroom mirror or on some sort of surface that you had at home, like a window or something. We're going to take that data and figure out how to graph it in a spreadsheet program. So we're going to use Google Sheets. So I've already kind of preloaded a Google Sheet here. And the first thing I'm going to do is I'm just going to find the data right here, and I'm going to copy it all. I'm going to Command C, or you can Control C, whatever works on your keyboard. And for now, I'm just going to kind of pick any cell in the top left here. It's not going to matter hugely what you pick, but just you'll be able to move the data around later if you need to. And then I press Control V or Command V. So it's the paste feature. Alternatively, you could right click on a cell and then paste. I'm using a non-Chrome browser, so that could be why that happened. So I'm just going to go back and do my Control V because I know that works. So the next thing is, okay, we have this data. So let's first figure out what are our labels for these data, for this data, or for these data technically. Did you know that data is a plural word? Data, these data. So I'm going to bold these just so that I can see them a little more easily. And some of the wording here is getting cut off and right here. So what I can do is I can click, and if I click just these cells or these columns right here, I select them individually. But if I hold down the Shift key when I select them, then I can select all of them. And if you move your cursor so that it's right between the column headers and double click, what happens is that it will automatically adjust all of the different columns so that they are the appropriate width for whatever the widest cell is in that column. Okay, so now you notice that F is wider than G. It's wider than E. But B is wider than E because E doesn't have very wide data. So anyway, this is just a visibility thing. You can adjust the column width anytime you want, for any of you who don't know that and haven't used spreadsheets before. And again, if you want to update, if you want to like auto fix the position of one column divider, you can just double click on the one column divider and it will resize that one column. Okay, so at this point, what we have to do is we have to first look at what our what do we want this data to become, and in terms of a visual representation. And what you may have done in the past is you may have taken data and turned it into a graph. Okay, so let's say we're making a graph with this data. One thing we can do is we can just take the data and select it all. Maybe let's just select it all, right? And Google Sheets has a built-in graphing tool. So if you go to Insert and go to Chart right here, that will insert a chart for your data automatically, okay? And so we could say, hey, we just did it. We made a graph, done. But we have to make sure that the graph makes sense and that it's actually showing us what we want it to show. Because spreadsheet programs can be pretty amazing and user-friendly. And sometimes they can figure out what it is you're trying to show, and sometimes they can't. Okay, so just from selecting all of that data and then looking at what we see in the data, there's these three different colors being used: blue and red and orange and yellow. And so it looks like what I'm actually going to close the chart editor for right now so I can have everything on one screen. Maybe I can just do this. Maybe. I'll open that back up again later. Okay. Move this over a little bit. There we go. Okay. So now we can see the data and the graph of the data, the representation of the data. Okay. So one of the things I noticed at first is that there's 3 colors. Okay, blue, red, and orange, or yellow. I think it's orange. We have to figure out what do those colors mean. Okay, there's a legend up here that says the colors blue means that that bar is showing a layer of fabric. Okay, and the red is showing distance, and orange is showing temperature. Okay, so then the bars are showing like how far or how large of a magnitude we have for that that data point. So like with the cloth mask, if we look at cloth mask in the data table, there's 3 different trials that were done with a regular cloth mask, which is not filtered, but a regular cloth mask. Okay. So what I can notice is that these 3 rows right here, there's 3, right? And then over here with cloth mask, there's 1, 2, 3 columns of cloth mask. Okay, so maybe that means that each cloth mask data like position on the x-axis right here, each of these positions on the x-axis corresponds with one of these rows. Okay, so then what the next thing is to say, okay, let's say this cloth mask column instead of that, or that one and that one, this right here is representing just this row of data. So these 3 bars, blue, red, and orange, are representing that row of data right here. So cotton, there's 1 layer of fabric. So layer of fabric, blue, is that 1? I click on here and find out. Yeah, 1. Okay. And you can move over here and see that if this scale right here was a finer or a more granular scale, meaning that if the scale showed you 1, 2, 3, 4 in addition to the 5, it would be easier for you to visually see, okay, is that 1 or is it 2? The blue is not past the halfway point, so it's probably less than 2.5, which is half of 5, right? So it's less than 2.5. So if we're guessing, then the bar is probably at 2 or 1. And here the spreadsheet system tells us that it's 1. So that matches up. So then the distance that my face was from the mirror in this case was 4. Okay. I would love to see units right here. So when you record any data table, always write your units, because I don't know if this is 4 inches or 4 centimeters or 4 millimeters or 4 miles, right? So I have to guess unless you tell me. So some of you might not know that when you're editing a cell like this, by the way, that you can do what's called a carriage return and move your cursor down to the second line. A lot of you might have experienced if you press return, then it just moves you down to the next cell. But when you're in there, if you press command or control and then press return, then you get that second line. So I'm going to put inches there just so I have it. Okay. And if you want, you can format it. There we go. So again, we're looking at this first row of data. So 4 inches. So we're saying that in this trial, this data test, okay, I'm wearing a cloth mask with 1 layer of fabric and my face is 4 inches from the mirror. Cool. So distance, if I'm labeling this, I should probably say distance like from the mirror, right? So what I want to do is actually, maybe I'll shorten the word inches. Inch distance from mirror. That way my label is more specific, so that if someone, like if I'm using this graph to help someone else understand what my data means, right? If it just shows distance, they're not going to know as easily what we're talking about. But let's say you're like talking to someone who you know who is a mask skeptic, and you're trying to help them understand what this data means. Like, you want to make your labels really clear so that they can relate to it, and right away in their mind have a sense of what we're looking at. Okay, so distance from mirror. I can even be more specific. So I double clicked to edit that. I might even be more specific. So I might say distance of face from mirror. Okay. So in inches. So the cloth mask in this first trial, 4. So you can probably guess that where the bar is in relation to 5. So 4 inches from the mirror. So that is confirmation that we're still in this row of data right here. So, and then 1.5 diameter breath mark. Okay. So this is where I'm a little bit confused because, right, shouldn't we have 1.5 on like as a bar here somewhere? Like, why is diameter of breath mark not appearing as one of our variables? Right? So you might have done this and you're like, but I have the data. I don't understand what's going on. Okay, so we'll talk about that in a sec. Let's move ahead to the last column that we see here, cloth mask. Or sorry, yeah, we're looking at a cloth mask. This is temperature. So our temperature data point. So temperature, in this case, is 25. But again, I don't know if this is degrees Celsius or degrees Fahrenheit or degrees Kelvin. And if this is 25 degrees Kelvin, that's almost absolute zero. That's real cold. So I think a lot of people are probably generally going to be thinking, a lot of Americans at least, are probably going to be thinking that this is degrees Fahrenheit. And 25 degrees Fahrenheit is below freezing. So, or below the freezing point of water in degrees Fahrenheit. If you've ever been to an area that experiences snow, you might know that like 25 is when you might have snow. So again, we want to update our label and just make sure that we're being extra clear about what we're looking at here so people can understand. Because otherwise people might say 25 degrees, that's not around here. So there's sometimes I really should figure out how to make the degree symbol on my keyboard. Right now, I'm going to pretend like an asterisk is a degree symbol. So I don't think that's technically like accurate. I wouldn't publish that anywhere. But you get the idea. I just want to show that this is a degrees sign. And I don't want to write out the word degree just because it takes up more space in my my legend at the top. And pretty soon we're going to need a little more space for another label. So what I'm going to do is I'm going to make a little, you could just say C, and people will probably understand, but I might do that. Just, again, I just kind of like having a symbol there to show like a degree symbol. Okay, so what this is showing us again is that in this first cloth mask trial, it was 25 degrees in the bathroom, according to the thermometer that was used. The person's face was 4 inches from the mirror, and there's 1 layer of cloth fabric in the mask. Okay, so let's figure out why then isn't our diameter breath mark showing up? So the reason is that one thing you might notice is that in this column, D, E, and G, where is the number in relation, like where in the column or in each cell is the number positioned? There. Okay, the numbers are on the right side of the column. The fact that the numbers are on the right side of the column by default means that the spreadsheet system understands those, the numbers you've entered. The spreadsheet system understands those to be numbers. In here, whenever there are values on the left side by default, usually that means that, or often that means that the spreadsheet system doesn't recognize those as numbers. Okay, it recognizes those either as letters or some other combination of letters and numbers and possibly symbols. So if I were to write a word like hello there, that's going to be on the left side. Whereas if I write a number, 78, it appears on the left while I'm editing, but then when I press return, it goes to the right. Okay. Whereas if I say I'm 78, right? That's on the left because it's a combination of letters and numbers. So now knowing that, I'll put that back. So now let's look at these. So what do we have to do to fix these? Or I should say, what do we have to do to fix these so that the system recognizes them as numbers? Okay, so we have to make these look more like numbers that are in a numeric format. So 2.5, I'm going to change that to put it in a decimal format. 2.5. Okay, so when I press return, system understands that to be a number. 1.5, 1.5, number. There's something happening now. Okay, what just happened? Okay, I just made a change, and now our graph has changed. So now, instead of having 3 types of things up here, we're going to call these variables, 3 variables, because they are values that vary, right? As I do this and change this formatting of the number, now the system's starting to see like, hey, there's another column here and it has numbers, and we have a vertical scale that is numerical, and so we can start putting those numbers on the numeric scale. Cool. So some of the colors got changed, right? Like, and this is interesting because now our labels are a little bit mixed up. So let's finish reformatting the numbers and then we'll fix that. So 4.5 is 4.5. Nothing. So numerically, what is nothing? Right? Diameter of breath mark. If there's no breath mark, the diameter would be 0. Okay. And half. So 1/2 inch and then 1.5. Okay, so now we have this other variable. Again, a variable is like a description of a value where the values vary. Okay, all of these are varying. Even though these numbers don't vary, they could vary, right? The temperature could vary in different situations with different bathrooms, different rooms in the house, and so it's still considered a variable. So all of these are variables: type of mask, type of fabric, type of layers of fabric, etc. We'll get into that in a little bit. Let's first fix our labels here. Okay, so we have to make sure that our colors are matching up with what's over here. So blue, layers of fabric. Does it seem like blue still represents layers of fabric? In our first cloth mask trial, 1 layer of fabric, cloth mask trial, 1 layer of fabric. Cool. So we should see 3 data points in the graph that have 1 like 1 as their layer of fabric. So we look over here, 1, 1, and 1. Cool, so we're good. And then we should have 3, 3, and 3 in the last 3 data points. So 3, 3, and 3. Cool. So this checks out. So the blue color actually represents layers of fabric, like it says. Distance of face from mirror is supposedly red. Let's check that. If we're looking at cloth masks, those 3 data points, we have 4, 2, and 1. Okay, so 4, 2, and 1. So that checks out as well. Actually, all of these are 4, 2, and 1. 4, 2, and 1. And then over here, 4, 2, and 1. So that checks out as well. Red actually is distance of face from mirror. Yellow, temperature, degrees C. Okay, so no mask, like the first trial we have here. This spreadsheet says that value is 2.5. But when I look over here, 2.5 actually represents the diameter of the breath mark. So I think that this label might be inaccurate. The spreadsheet system thought that it was accurate, but it's actually not. Okay. So what we have to do is just double check and triple check that we think that yellow means diameter of breath mark or represents diameter of breath mark. So here, the second no mask trial, diameter of breath mark is 5 inches. I think it's inches. Again, there needs to be a label here. There should be for what the units are. I'm pretty sure it's inches, so I'm going to put inches. Make sure you have inches in your table and then in your labels as well. Okay. And then this third data point, 5 inches again. Yes, that should be, so this should be diameter of breath mark. So I'm going to double click here, and I'm going to double click again and change this label. So diameter of breath mark in inches. Cool. And so now we can just confirm that green represents temperature. These are the biggest numbers by far. They're 25. So that's pretty safe to say that green does represent temperature. But what is it temperature of? Is it temperature of your breath? Temperature of like the bathroom mirror? Temperature of the bathroom air itself? Well, that depends on where your thermometer was and what it was taking the temperature of, right? So if you put your thermometer and just had it sit out in the bathroom, then this is probably temperature of the air in the bathroom. Okay, and then in what units? I think we're working in C still because I don't think this bathroom is frozen. The freezing point of water in Fahrenheit is 32 degrees. So 25 is below 32. In Celsius, water freezes at 0. So two different measurement scales. We'll get into that later. But so you might have used a different kind of thermometer, maybe. Like maybe you had an infrared thermometer and you measured the temperature of the mirror surface itself. So in that case, you would just specify what temperature you were measuring. And that's going to be really important because different people might have used different thermometers. Like if you had a thermometer that you preferred to the one in your chemistry kit, you just want to make sure that you're specifying, and I will be looking for this when I'm assessing your graphs. I will be looking to make sure that your labels are very specific to what you actually measured. If they're not specific, then your data is not, and your graph is not as universally communicable, meaning that it's not like it wouldn't be possible for lots of people to understand it in the same way. Let's see. So at this point, we have all of our variables. And I think the last thing that we need to do for now, this is like a level 1 video. Last thing to do for now is add some general labels to these axes. So x-axis and y-axis. Okay. And then to the whole graph as a whole. So you can double click on the graph to bring up the chart to bring up the chart editor. We're going to use the term chart and graph pretty interchangeably. So in here, you can edit the chart and axis titles, and that's what we're looking to do here. This is a drop-down menu, so if we're trying to edit the horizontal axis title, then if we test it, where is that going to show up? It shows up below here. So we need to think of a title that represents all of these. Okay, so what do you think is a title that could represent all of these variables together? If we were to say like type of what? Okay, so maybe type of mask, right? Type of facial covering, right? So you notice that these 4 labels ended up here as part of our legend. But this one and this one didn't, right? So that's important to note. Okay, so what we're doing here is we're identifying type of mask is kind of how we're going to generalize all of these names. Type of mask. Or type of facial covering. Because you might not have tested with like an official mask. You might have tested with a towel or a t-shirt or something. So maybe we'll just say like type of facial covering, just to be more general. And then what if we look at the vertical axis title? Okay. So here's the thing. In this case, our y-axis is set up with numbers, but some of these different variables here, as they vary, their numbers change, but they use different measuring units, right? So if we're measuring the temperature of air in the bathroom, we're still using numbers for measurement purposes, but we're only using numbers, like the numbers are being measured in degrees Celsius. So it's a different unit. With the red and the orange, we are still using numbers, but they're different units, right? So these are inches rather than degrees. So these are length measurements, and this is a temperature measurement. And the blue layers of fabric, that's just a quantity measurement, but it's still a number. So we have quantity, distance, and temperature. Okay. So there's 3 different types of units actually being measured on this vertical axis. And so this is why this is a much more complex graph than what you may have made in the past, because in many situations what you do, especially when you're first learning to graph with a spreadsheet, is you might just graph a little bit of data where, let's say you're just graphing this data and you chart that. Okay. And let's say we want to actually use a different chart type. I don't want a column chart this time. I want a scatter plot. So like I'm not going to really explain this right here, right now, but we'll get to this in a later video. But so what I'm doing is I'm trying to see like, okay, there appears to be this downward trend and there's only 2 colors, right? There's only one type of thing here. This graph doesn't really show much right now. It's not configured very well, but there's a lot less data. So if you were trying to figure out like, how would I make this graph mean something? Maybe I'll make like a pre-level 1 video on just graphing that and figuring out how to clean this data up to make that make sense. But suffice it to say, like the big idea is that this is the one that we're working with is a relatively complex graph because there's a lot of information and because we are using a number of different types of variables. So I'm going to give you some language here and then we'll finish out this level 1 video. So you might have heard of independent variables and dependent variables. Okay. And one way that I like to define these, like independent variables, if you start in a cell with an equal sign, then the spreadsheet system thinks that you're about to enter a formula. So I need to be careful not to do that. So maybe I'll put like an arrow or something. So independent variables are variables that do not change as a result of changes to another variable. So in other words, these are variables that are not dependent on another variable's value. Whereas a dependent variable, these are variables that are dependent on the value of other variables. So these are variables that do change, or could change, I should say. Could change as a result of changes to other variables. Okay. So you'll notice that this word dependent is, I put that in there intentionally, right? So for example, let me think of a good example here. So what we're doing here is we're changing the type of facial covering. Okay, that's what we change. You were able to say, I'm going to use no mask, and then I'm going to use a cloth mask, and then I'm going to use a filtered cloth mask, right? The temperature of the bathroom did not determine for you what type of mask you chose. The type of mask you chose was not dependent on the value, like the number of layers of fabric, right? You just decided independently that you were going to say type of mask, I'm going to do it. Okay. And so then we have, like, let's say, because within one row, if we have no mask, then once we choose no mask, then what are the variables that are part of that are involved? So what we want to try and do with setting up a graph or setting up a chart like this is see if we can identify, is one variable or is a change in one variable causing a change in a different variable. So if I change the type of mask, right? Because one of the independent variables would be type of mask. It's something that we are changing. So if I change the type of mask, how does the layer of fabric change in response? So in this case, would you say that changing the type of mask changes the layer of fabric in a dependent way? Like, is layer of fabric dependent on the type of mask you choose? Yes, I would say so. So in that case, layers of fabric would be a dependent variable. Okay. So in that case, layer of fabric is dependent. Let's look at something else. So if we choose the type of mask, is the distance that we are choosing to be from the mirror dependent on what type of mask we choose? Not really, no. Right? Like if you choose no mask and then you choose cloth mask, you are able to choose the distance from your face in the mirror independently of the type of mask. So actually distance from the mirror is also an independent variable. Okay. So now we have two independent variables, like two things that we are changing, right? We're changing the type of mask we have, and we're changing the distance from the mirror. Layers of fabric, we're not directly controlling. Those are changing as a result of these. Let's look at diameter of breath mark. Okay. Do we control the diameter of the breath mark? Like, is that something we change directly, or does that depend on one of these other variables? It appears that this will be determined by what type of mask you choose and actually by the distance you are from the mirror. So it seems like the diameter of the breath mark is actually a dependent variable. Okay. And then the temperature in the bathroom, is that an independent variable or a dependent variable? Like, what are you, do you change it? Like, do you have control over the temperature of the bathroom? I mean, sort of, right? Like, if you wanted to change the temperature of the bathroom, you could probably run the shower for a little bit, and it would make the bathroom a little bit warmer. You may be able to run the shower cold and cool down the bathroom too. It's possible. You might use a lot of water that you don't need to use, um, but so, but is the temperature of the bathroom going to change in a dependent way based on what type of mask you choose or how far you are from the mirror? No, it's not. So the temperature is not dependent. Um, it's not exactly independent because you're not really like you're sort of in control of it. Some people might consider temperature to be a controlled variable, meaning that you are controlling it and keeping it constant. Some people might consider this to be an independent variable because it's kind of independent of other things. So what I'll say here, independent or control, temperature of bathroom. Okay, so at this point, we've identified some independent variables that we're using, some dependent variables, but we still haven't been able to tell if one of these affects the other. And you can look at the colors here and see that, oh, the yellow goes up and then down and then up and then down and then sort of up. And the blue is not there and then it's flat and then it's flat. The red, there's sort of a trend downward and then up and then downward and then up and then downward. So we have to dig a little bit more into how to analyze this graph. And I think we need to actually break it up a little bit maybe, or reorganize it. Because one thing that this graph is doing is I think it is treating all of these variables here that are vertical bars. The graphing system thinks that all of those vertical bars are supposed to be dependent variables. But distance from the mirror shouldn't be a dependent variable. And the temperature of the bathroom shouldn't be a dependent variable. So we're going to need to reorganize the data somehow. And that'll be the focus of the next little bit.